So you see, in this problem, we have to find a reaction forces at point A and at point B. You see, at point A, due to roller joint, we have a vertical upward reaction force, and at point B, due to pin joint, we have two reaction forces. One is a vertical upward force, while the other is horizontal force. And you see, on this rod, we have two load distributions. One is 600 Newton per meter and the other is 900 Newton per meter. You see, this 600 Newton meter force makes a rectangular load distribution. And you see, this 900 Newton per meter makes a triangular load distribution. And you see, each side is about 300 Newton per meter. And you see, this rectangular load distribution acts at the center of the rod, while the triangular load distribution basically acts 1 meter away from point A in the right direction. So this is the free body diagram. So you get a clear picture about load distribution. You see this is the rectangular load distribution and this is triangular load distribution. So let's apply the moment at point B to get the vertical upward reaction force at point A. You see, we get this 600 multiply 6, which is the rectangular load distribution, and it has a perpendicular distance of 3 meters. And we have this triangular load distribution. And you see, we have a perpendicular distance of 5 meters, and this vertical upward reaction force, which has a perpendicular distance of 6 meters. And you see, it is moving in clockwise direction. So it is negative, and the other forces are positive because they are moving in anti-clockwise direction. You see, it is basically moving in clockwise direction. So through this, we get the reaction force at point A, which is about 2.175 kilonewtons. And in order to find the reaction forces at point B, we can apply the moment at point A to get the vertical upward reaction force at point B. You see, we get this reaction force at point B in the vertical direction with a perpendicular distance of 6 meters. And you see, we get the vertical load distribution and a perpendicular distance of 1 meters. And we have the rectangular load distribution and a perpendicular distance of 3 meters from point A. And you see, these two forces are moving in the clockwise directions, so they are negative. So we get the vertical upward reaction force at point B, which is 1.875 kilonewtons. And in case of the horizontal reaction force at point B, we can take the force in the x direction, so we only get the horizontal reaction force at Px. So we have no other reaction force that is acting, or no other force that is acting in the horizontal direction. So you see, basically this force is equal to 0. So reaction force at Px is equal to 0, or in the horizontal direction.